Welcome to the deep dive. We're plunging into that intricate, often unseen world behind the artificial intelligence models that, well, increasingly shape our daily lives. Have you ever wondered what really happens before an AI product lands in your hands, making your life easier or, showing you something new?
Well, today we've got a really unique set of sources for our deep dive. We're not just looking at dry technical documents. We're exploring this collection of evocative audio excerpts. They're almost like modern digital ballads, actually. And we've got a comprehensive briefing document alongside them.
Ballads. That's interesting.
Yeah, they capture the raw human emotion, the intense technical struggles, and also the soaring aspirations of the people building this AI. So our mission really is to give you a shortcut to being genuinely well-informed about the whole journey, from an AI model's like a first spark of an idea right through to its complex real-world deployment.
That's fascinating. So, okay, this isn't just code and algorithms then. It's
Yeah.
deeply about the people. The sources talk about long hours, little rest,
Yeah,
people pouring themselves into these creations, facing failures that apparently don't defeat, but make the triumph sweet.
exactly.
It really highlights the personal investment, doesn't it,
Yeah.
behind all the tech we use. So, all right, let's unpack this. Let's explore the uh, human story inside the machine. Our journey starts, well, right at the beginning. The first spark of AI life, data.
hmm
You hear these models described as perpetually data hungry, constantly reaching for what they can learn, like this insatiable appetite, always consuming.
And this hunger, this need for data, it's especially acute right at the start. It's a huge challenge called the cold start problem.
Mm,
That's when a new model, or maybe a model seeing new users, has basically no history, no past data to learn from, so making accurate predictions almost impossible.
right, a blank slate.
Precisely. One of our audio pieces, Cold Start Problem, paints this picture really vividly. No past clicks, no likes, no trails to find, just a cold start model lost in time. It's almost poetic, isn't it? This machine kind of yearning for human interaction, pleading, feed it your trails, your heart, your form, help my cold start model get warm.
Wow. So the key thing here is despite how autonomous AI seems, it's born from and relies on us, humans,
Yeah.
especially early on.
Absolutely. It forces you to rethink that whole machine versus human idea. It's much more machine with human.
Okay, so the model gets its first taste of data. What's actually powering the learning then? The computational muscle. We hear about racks and racks of GPUs. You imagine it's impressive sight,
Oh
right?
yeah, it's serious hardware.
But what's really interesting is how quickly, even with all that power, the sources bring up these very real human constraints.
Mhm.
And there's another track, GPUs are killing me. And it laments, they're killing me for my AI dreams, but they're gold. I can't afford. It's a powerful reminder, isn't it? Even in this super high-tech world, basic economics, the cost, it's a constant reality. It really impacts what developers can actually build.
Absolutely right. And once you have the data and you hopefully have the hardware, the process shifts. It moves into what we call iterative refinement. And this isn't a one-shot deal. It's a continuous cycle of adjustment. One source calls it a developer's prayer, watching the loss go down in prayer. That's from down on the server farm.
Watching the loss go down sounds intense.
It is. It involves constant tweaking, cutting the losses, easing the pain, and relentlessly trying to beat benchmarks. Keep on training talks about that. It really makes you ask how much human patience, how much sheer dedication goes into making these machines learn slowly, painstakingly. It's way more hands-on than people think.
But training isn't just shoveling raw data in and hitting go, is it? There's an art to preparing that data. Feature engineering.
Indeed. Yeah, feature engineering is crucial. A feature, for anyone maybe less familiar, is just an individual measurable property, something about what you're observing. And feature engineering is the whole process of using domain knowledge, your expertise, to select and transform that raw data into these useful features. Features that can actually predict something.
Okay.
One of the ballads, beautiful feature, calls it, "Oh feature, oh treasure, in the stream you flow, unlocking the secrets we long to know." It's about finding and crafting the right inputs. And sometimes it's about making connections, like this cross-feature duo idea, where maybe two pieces of data, two lonely columns, didn't seem related.
But together they mean something.
Exactly. Together they create synergy. As cross-feature duo puts it, they end up predicting the clicks hand in hand. It's creative. Human-driven insight, finding those hidden links that unlock the model's potential.
So training, vital, clearly. But it's just the start. Then comes the really tough part, maybe? Testing. I can imagine the initial excitement seeing metrics that look amazing, almost too good to be true.
Oh, definitely. That happens a lot. Often it shows up when a developer sees a perfect ROC curve. ROC stands for Receiver Operating Characteristic. Basically, it's a graph showing how well a model distinguishes between classes. A perfect box shape, like in the line from my ROC is a BX, my ROC is a B up, so sleek, numbers align, they make me weak, suggests zero trade-offs.
Which is suspicious.
Highly suspicious, yeah. It's usually an immediate red flag. That perfect score often turns out to be, well, a flawless mirage. It leads to this inherent skepticism in the field. You learn to question great results initially.
So after that initial, maybe false high, how do developers check if the results are actually meaningful?
Right. Then comes the grind for statistical significance. This is a really persistent challenge. You calculate a p-value, which tells you how likely your result is just due to random chance. If that p-value is too high, you can't be confident. Your findings could be noise. Hard to get stat. StatSig captures this perfectly. Oh, static, where'd you go? I chase you fast, but you move slow. The p-value's too high. The doubt does grow.
Sounds frustrating.
It is. And similarly, you've got the calibration blues. That's the constant effort to make the model's predictions actually match the truth, acknowledging that a perfect fit is so hard to find. It's about ensuring that the model's confidence levels, its probabilities, align with reality.
Okay, so beyond those stats hurdles, what about the sneakier problems, the hidden pitfalls that can undermine everything?
Yeah, our sources point out several tricky ones. One big one is selection bias. Essentially, your training data isn't representative of the real world. Think of like trying to understand global fashion just by surveying people at one fancy ski resort. Your data's skewed, right?
Hey, your model learns the wrong thing.
Exactly. Selection bias warns it's a tangled snare caught in webs we're unaware. It can deeply distort results without you even realizing it at first.
Yeah.
Then there's this beast called heteroscedasticity, which apparently is breaking my sleep.
It sounds complicated.
It just means the errors, the noise in your model's predictions aren't consistent. Imagine predicting something, but your errors are huge for low values and tiny for high values. This ununiform noise makes predictions really unreliable. It affects how much you can actually trust the model's output.
And one thing that seems to keep coming up in the sources is this big gap, this disconnect between offline testing and real-world performance. Why is that? Why the difference between the lab and the wild?
That's a core battle for every AI developer. Mystery in the code describes it so well. An offline heart beats strong but slow, but online whispers a code I can't find. Offline, you've got nice, clean, curated data, controlled conditions. Online, it's chaos. Constantly changing user behavior, new data patterns, unexpected stuff.
The messiness of reality.
Totally. It's that frustration, like another source says, of staring at a scatter plot and asking, oh, why won't you meet me on the x equals x? Meaning, why don't my predictions perfectly match what actually happens? This gap, simulation versus reality, means developers are constantly trying to bridge it. Learning that a truly robust model isn't just good in tests, it holds up in the messy real world.
So after navigating all that testing, the minefield, as you called it, the goal is launch. Get it out there. There's this real drive, isn't there? Launch my model, looking fine, pass the test, and cross the line from launch it now.
Yeah, you can feel the urgency.
And the relief when it finally works. It finally works. The code's in sync. All the gears turn without a kink. That's from it finally works. You can just imagine that feeling, all those late nights paying off.
Oh, absolutely. Huge relief. But even at this stage, it's not always smooth sailing. A big bottleneck mentioned is waiting for engineering. The machine learning model, it needs a home, a pipeline lost in digital strain. All of this waiting is a pain. That's from waiting for engineering.
So the model's ready, but the infrastructure isn't.
Pretty much. It's compared to a scientist waiting on the track for that data train to come rolling back. You're dependent on other teams, other systems, to get your model fully integrated and running. Launching isn't a solo mission, it's this complex coordination.
And then the moment of truth, deployment, and the fear, the very real fear captured by my experiment broke the site. You can just feel the dread. Stomach drops like a roller ride, heart can't hold it open, and wide metrics tanked users out the door.
Oof. Yeah, that's the nightmare scenario. Seeing your hard work actually cause problems for users, the stakes are incredibly high. But what's crucial and maybe surprising is that even after a successful launch, the work isn't over. It just shifts. It becomes constant vigilance.
Monitoring.
Continuous monitoring. Like in Quiet Night of Models Log, developers are watching for tokens all night long, looking for anomalies, performance dips. It's not a finish line, it's a continuous loop. A cycle we're in, as another track says. You shift, I break, we start again.
Wow. So continuous improvement isn't just about the next version. It's about keeping the current one alive and well.
Exactly. AI development is really an ongoing relationship with the deployed system, a constant dance of adjustment, refinement, even out there in production, just to keep it effective and stable.
Okay, let's dive deeper into some of those core challenges that seem to persist throughout this whole life cycle. Yeah, we keep coming back to data, right? But specifically, the messy reality of it in day-to-day operations. The sources talk about data silos, these isolated pockets of data that hold me down like floodwater on my old hand. Sounds really restrictive.
They are. Silos prevent models from getting the full picture, all the information they might need for a truly holistic view, makes comprehensive analysis incredibly difficult. And then there's the data format war, this clash between, say, JSON, which is often easier for humans to read,
Clear, yeah.
and something like Parquet, which is built for speed and efficiency, especially with huge data sets. It's this constant tug of war, developer convenience versus raw computational performance.
And it sounds like just keeping the data flowing smoothly is a challenge in itself.
Yeah, definitely. Developers face constant disruptions from seemingly small things like needing one more column or one more table. Each change can force reruns, cause delays. It adds up. Then you have the really pervasive issue of data drift. With ephemeral IDs, shifting sands, data drift is when the underlying patterns in the data change over time.
So the world changes and the model gets out of date.
Essentially, yes. The statistical properties of the data evolve, and covariate shifts change the game, highlights a specific type. The world is turning, the trends are, the datas are changing. This means what the model learned yesterday might not hold true today. It constantly challenges the model's relevance and performance.
And with all this complexity, sometimes the models themselves become, well, mysterious, the black box problem.
Oh, the little plot goes a long way, expresses this so well. My mind can't make sense of a score on its own. It's just a number, a lonesome stone, right? You don't get the why. Precisely. The black box problem is that lack of transparency. It's hard for us humans to follow the internal logic of these really complex models, and the solution mentioned. Surprisingly simple, but powerful. So give me a pie. Yeah, a little plot goes a long, long way. Visualization.
Just drawing a picture helps.
Immensely. Simple plots, charts, they can shed so much light on why a model made a certain decision. It helps developers, helps users understand the reasoning, not just see the output. And that demand for interpretability, it's growing.
What's really striking here is how these technical struggles seem to lead to almost emotional descriptions of human-computer interaction. The sources portray models with desires.
It's true. It's quite fascinating. There's the model sort of wanting user engagement, asking, will you click? Will you see me here? From a gentle tap. It seems to yearn for that validation click. But then there's a darker side mentioned, a jealous machine that craves constant glare, constant attention.
Oh, jealous machine.
Yeah. It suggests we're building systems that, maybe through our own design choices, mirror aspects of human psychology, that need for interaction or demand for attention. It really raises a big question, doesn't it? What does it mean when we create systems that seem to have these human-like traits? Are we just reflecting ourselves?
And despite all this struggle, all the late nights, the bugs, the data problems, what keeps people going? The underlying motivation seems to be this pursuit of progress. Even a tiny lift born from a dream or just a little metric lift is worth it because, as one source puts it so profoundly, knowing somewhere little or led makes my struggle worth every bit. It comes back to impact.
Making a real tangible difference, and that really speaks to the resilience, the persistence needed here. Failures come but don't defeat. Each misstep makes the triumph sweet. That line, again, it just captures the spirit. It's about that constant dedication to keep on training and holding on to that belief that there's hope in the logs, that you can figure it out, find the solution, even when, as one source just bluntly puts it, everything's broken. It's really a testament to the human spirit, isn't it? Pushing boundaries, finding answers where maybe none seem to exist at first.
Well, we've certainly covered a lot today, a real deep dive into this complex, challenging, but also, ultimately hopeful journey of AI model development. We've heard about the digital dilemmas, the empirical blues, and just the tireless effort behind even a little metric lift. It's so clear there's immense human ingenuity, perseverance, and surprisingly, a lot of emotional investment behind every AI system.
Absolutely. And if we connect this back to the bigger picture, it's clear that this profoundly human process, the intuition, the problem solving, the empathy, the sheer grit, It's inseparable from the tech advancements. That's what actually brings these systems to life and makes them valuable,
Yeah.
way beyond just the code itself.
Indeed. And maybe it leaves us with this final thought to chew on. Despite all the sophisticated algorithms, the massive computing power, so much of AI development still feels like a deeply human endeavor, filled with those long hours, little rest, the constant search for truth in the numbers, even when everything feels broken. It makes you wonder, doesn't it? As we empower these intelligent systems, as we give them these almost human-like characteristics we heard about, are we truly building something entirely new? Or are we maybe just reflecting our own persistent struggles or aspirations, maybe even our own yearnings, back at ourselves in digital form?